Alright, so this is going to be the first part of the extra credit, and it's to find an organic compound, which I chose capsaicin, with a or more functional groups that must contain an oxygen containing functional group slash nitrogen containing functional group and one other functional group. Alright, so I chose this one because we have a nitrogen functioning group and an oxygen functioning group. We actually have two, I believe. Alright, so we're going to start by circling all of our little groups. So we have this one right here, and we have this one right here, and we have this one right here, and we also have this one right here. Alright, so let's start by naming each one of them. So according to the chart right here that we have over here, this one is going to be this one right here, so that's going to be phenyl. This one right here is an O, an oxygen between carbon and a carbon, and that looks like it's going to be right here, so that's going to be a ether. All right, so here we have our nitrogen bond over here, and we have a double bond, so this limits our options to only these right here, and that is going to look like this one right here, because it's the only one that contains a nitrogen. As you can see, none of these have a nitrogen in them. So this one is going to be an amide. All right, and then this one right here is a carbon, double bonded carbon with hydrogens on each side, and that's going to look like it's going to look like an alkene. Alkene, I believe that's how you pronounce it. An alkene. All right, so that's the first part of this, and now we're going to start what's it called? We're gonna start, I forgot what it was called, but we're just gonna start identifying each of these elements. So we're gonna start with oxygen over here. So according to bonding rules, oxygen wants to have two bonds and two lone pairs. So it has a bond over here with the hydrogen over here. So it has, I'm gonna write it down over here. So oxygen has two bonds, two lone pairs. And that equals to, two lone pairs because it wants to have two lone pairs, so I'll just draw those right here. Yep, okay, and then that's going to be sp3 because draw our fingers, 1, 2, 3, 4, sp, p, p, because there's 2 plus 2 is 4, spp, sp3. All right, so then we're going to start with electron geometry, not molecular. Electron geometry and molecular geometry. All right, so for electrons, as we have two bonded atoms, or since total we have four lone pair, four electron groups. That's going to be 109.5. 109.5. Molecular geometry, since there's two lone pairs is going to be bent, and that's for oxygen right there. Now let's keep on going from left to right. It's going to be this carbon right here now. So carbon, according to bonding rules, wants to have 4 bonds and 0 lone pairs. So this carbon right there is going to be like this. There's already 3 bonded atoms, and it has a extra bond over here for a hydrogen. So it's going to have 4 bonds and 0 lone pairs. That's going to be sp3 as well. And its electron geometry and molecular geometry is going to be, since it's 4 bonded atoms, it's going to be 109. 0.5, and its molecular geometry is going to be, since it has 0 lone pairs, it's going to be a tetrahedral. Tetrahedral. All right, we move on. Now let's go around the circle, around the hexagon. I mean, this way. We can go either way. Let's go this way. All right. So this is another carbon over here, and it has 2 bonds, and it wants to have 4. It's going to be hydrogen. So this one is essentially the same as this one, because they both have 4 bonds and 0 lone pairs. So I'm just gonna put a little star next to this one to identify that there's 1, 2. So there's 2 of them right here. I'm just gonna put 2 stars because these are 2. This is gonna be the same as well, because this is 2 hydrogens bonded to each other, 0 lone pairs. So that's going to be another one. I'm gonna put another little star over here. So there's 3 of them. And this is another carbon over here. Another carbon. This one is gonna have an H bond over here, and 1, 2, 3, 4 bonds. So that means it has 0 lone pairs. So it's gonna be the same one as this one, because it has 4 bonds, 0 lone pairs. So we have 4 of those now. And let's keep on going around the circle. Here's another carbon. Same deal. We have 2 bonded hydrogens, and 1, 2, 3, 4 bonds. So that's 4 bonds, 0 lone pairs. And that's another one right here. Let's move on to this one over here. We have another carbon. This carbon is bonded to this carbon, this oxygen right here. It just needs another hydrogen, and we have 4 bonded atoms. All right, so since we have 4 bonded atoms and 0 lone pairs again, we're gonna get another star. All right, so now we come down to the oxygen. So oxygen wants to have 2 bonds and 2 lone pairs. So we can add those 2 lone pairs over here. And since it has 2 bonds and 2 lone pairs, we just found another similar to the one we did before. So now we have 2 of them, because those 2 are similar. And then we have a carbon over here at the very end, and this one is a carbon with 3 H bonds. So it has 4 bonds with 0 lone pairs, and that's just another similar one to that one. And we move on. So we move on to this one over here. This is another carbon over here. We have another H. We have another H. 1, 2, 3, 4. We have 4 bonds and 0 lone pairs, and that equals to another carbon. We have a lot of stars over here. All right. So now we move on to the nitrogen over here. This one. So this is a new one. We haven't done this one yet. So nitrogen is bonded to carbon over here, a carbon over here. And according to our rules, nitrogen wants to have 3 bonds. And oh yeah, it's also bonded to the hydrogen over here. So it has bonded to a carbon. Oh, you can see bonded to a carbon, bonded to another carbon, and bonded to a hydrogen. So, and it wants a lone pair, so we're just gonna add a little lone pair at the top over here. So nitrogen, 3 bonded atoms, 1 lone pair. Add those up, you get sp3. Electron geometry, molecular geometry. Oops. All right. So electron geometry, since it has 4 electron groups, it's going to be 109.5, 109.5. 1 lone pair, it's going to be trigonopyramidal. Trigonopyramidal. All right, so that's it for that one. All right, now we have a carbon over here, another carbon. All right, so since it has 1, 2, 3, 4, satisfies the bonding rules, because it has 4 bonds, and it's bonded to 3 atoms. All right, so this is going to be a new one. It's going to be different than the other carbon. So carbon has 3 bonded atoms, 0 lone pairs. It has 4. This is the exact mistake I did in class. it has four bonds, but what we're looking for is bonded atoms. So it's bonded to 3 atoms because it's bonded to this nitrogen, to this carbon, and this oxygen, but it still has the 4 bonds. It's because of this little double bond. So don't be tricked whenever you're working this. All right, so 3 bonded atoms and 0 lone pairs. So it's going to be spp, so sp2. And then electron geometry and molecular geometry is going to be, since there's 3, it's going to be 120. Molecular geometry is going to be 0 lone pairs, so it's going to be trigonoplanar. All right, and we move on to the oxygen up here. Yep. All right, so oxygen is going to have, according to bonding rules, 2 bonds, 2 lone pairs. So it just needs 2 lone pairs right here. It has 1, 2, 3, 4, 2 lone pairs, 1, 2. All right, so this is going to be a new oxygen, so I'm going to make another one over here, oxygen. So it's bonded to 1 atom, 1 bonded atom, and it has 2 lone pairs. All right, so add that up, and it's sp2, sp2, sp2. All right, and then we're going to find the electron geometry and molecular geometry. All right, molecular electron geometry, since there is 3, it's going to be 120. Molecular geometry, since there's 2 lone pairs, it's going to be, wait, did I do something wrong? Oh wait, I think it's going to be linear. Yeah, it's going to be linear, I believe. It's not in the sheet over here, but I remember you said that everything ends with linear. So since there's nothing here, I believe it's also linear, because I got 2 lone pairs for this one because it's oxygen. So that's the one makes more sense to me. All right, so there's that one right there. And now we move on from this oxygen to this next carbon over here. All right, so now we're on to that carbon. And this one is bonded to 2 atoms over here, and since it wants to have 4 bonds, we're going to add 2 hydrogen bonds. And it's going to be the same as this one over here because it has 4 bonds, 0 lone pairs, so we're going to add another star. This is going to be the same thing, so we're going to add another star. This one is also going to be the same, this one right here, so we got another star. This one is also going to be the same, 2 bonded atoms and hydrogen bonds, so that's also going to be another star over here. All right, now we get over here to this little tricky one. So we have a carbon over here. We have 3 bonds currently, and we're going to add 1 hydrogen over here. All right, so now it has four bonds. So now this is going to be a different type of carbon, I believe. I don't think it's going to be any different. Could be the same as this one though, because we have 3 bonded atoms. So hydrogen, carbon, carbon. It is going to be the exact same as this one because it has 0 lone pairs. All right. So this one is going to be the same basically as this one because we have another hydrogen over here. We have 1, 2, 3, 4 bonds, and it's bonded to 1, 2, 3 atoms. And since it's bonded to 3 atoms, the 0 lone pairs is going to be exactly as this one. So we have currently 3 of these. I forgot about the other one. All right. And finally, we're almost to the end. We have another carbon over here. It's bonded to 3. Add another H. And now it has 4, so we're going to have another one of these over here. And there's another carbon over here. There's 1, 2, 3. Bonded to 3. 1, 2, 3, 4 bonded atoms. So then that's going to be another one. And finally, carbon over here at the end. H, H, H. And that's going to be the exact same thing. And that is the whole problem right there. That's capsaicin.